Alright guys, welcome back to the FreeCAD tutorial. We are now on part 5. If you were in my last video, we made this part. And we did it all doing the part design workbench with all these tools here. It's a kind of a wonky part, as you can tell. Don't know if you would ever have a purpose for that, but if you do, power to you, man. Power to you. But this was really just an example here. So we're gonna move, since we're starting on the part workbench, we're just gonna kind of move into that. We'll get rid of this one. It's taking a second. Alright. Now we're in the part workbench. So part design really works from 2D to creating like generating a 3D from the 2D shapes, doing revolves, pockets, pads, things of that nature. But this in particular, the part workbench in particular, it likes to more work in 3D. And I'll kind of show you what I mean here. By the way, I know I like to mention this in every single video, but let's say we create a cube here. I've done this several times in videos, but we can change data on like specific placement data, axis, position, that sort of thing in this data box. Whenever you click on the specific shape, it'll highlight green here, and we could change the view here. We could change the shape color. We'll change it to green. It's that's an ugly color, guys. Let's not do that. Orange. That's still an ugly color. Red, I like red. Let's find red. Here. That's good. Alright, we'll do red. Point color, line width. Change that up real big. Kind of ugly looking, so we're gonna change it back to what it was, but you can kind of get my point there and what it's doing. But in the part workbench, we mainly got like these tools here. I'm kind of putting my cursor over them. Things that may seem familiar from the part design workbench, maybe fillet or chamfer or revolve. These ones here, they work from sketches, and we'll create those using the sketcher workbench. I guess you could probably create them in the part design workbench, but I would prefer to actually create them in a sketcher workbench. So yeah, so like this is much more 3D because you got these buttons here that will do preset configurations of different shapes here. The cube, this thing's going to take you a long way. You can do a lot of modeling with this stuff, and you can get very creative with it, which is pretty cool. And it definitely challenges a person to think in 3D and how to manufacture something, and that it really helps quite a bit to the individual, that is. So here I am changing the length, the width, the height, in this data configuration and stuff, and that's the cube. So it's pretty cool. So we'll go ahead and hide that. Just remember to click the object and then space, and it'll hide the object. So now we're going to create the cylinder. So now we created the cylinder. We can do height. We'll do the height of 20. Big old radius, 8 millimeters maybe, and then we could change that angle around. We'll do 150. Why not? So it's pretty cool there. That sphere. So sphere's got a couple of geometries to it. Oh, gotta click on it. So you got the sphere radius. It's a little bit bigger sphere. We got one angle. So we'll change that to 60 degrees. Alright. You can kind of see what that's changing there. We got this angle. See what that's changing as well. We'll see that change live here. Alright. So that could very well be all kinds of pieces there. So that's very nice. And then this angle here. This is the vertical angle here, going through that Z coordinate system. As you can see, we just took a pizza slice out of that. Alright, see. So, another very, very strange part, but this is how you modify its geometries and stuff. You can also modify the placement. I mentioned that later. So, that's pretty cool. We'll do that. Another thing is you could change the angle. So this is the axis. If you're familiar with vectors, this is really good for you. If you're not familiar with vectors, I'd go ahead and maybe look up a few videos on basic 3D vectors and what the unit vector is and what it means and stuff. But that's basically what you're doing here, is you're making a unit vector in a specific direction on this XYZ coordinate system. So if I wanted to do it at triangle 1, 1, 1, or basically that's the coordinate at which the vector is pointing, or the unit vector is pointing. Not the unit vector, because the unit vector has a magnitude 1. And you would create an angle around that specific point. And you can kind of see here, you know, it could be around a specific axis, could be around the z-axis, that could be around the y, or the x specifically, or maybe a vector in that direction of 1, 1. Or 1, 1, 1, XYZ. So we'll leave it at that. So that's how placement works, and you basically change the variables of these based on that. So, and then we'll get rid of that geometry. Yeah, we got a bunch of geometries here, kind of nesting itself. So another strange part, just like the last few videos. I'm sorry if the parts have no meaning. I'm just kind of doing this kind of off the top of my head here. I don't have too much planning to it per se. So click on that. We got the second radius. So we can get this big radius, or we can get this really tiny one. So you can make like an arrow point maybe. You can get very creative with that. And then overall height. And then of course angle. Just like the sphere. This kind of takes like a pizza slice out. A big slice. Man, that's a big pizza slice if someone took that out. So pretty cool there. You know, maybe another interesting thing is you do the right click on the object itself and you click on appearance. You can actually change the material. Now this doesn't, I don't think this affects the FEM analysis whenever we get to there, which is the structural stuff, but it's kind of cool when you do that. See, metallized. So appearance. We'll do steel. Right? We'll do steel. Alright, so now that we've done the cone, let's look at the torus. So this is the torus. I apologize if I'm going a little bit fast. Sometimes it gets to be that way. I was actually modifying that one. But yeah, this is the angle of the torus. You know, maybe you're making, you know, part of a clip or something. This could be handy. And maybe a nose piercing if you're into that. And then angle. Kind of see what's going on there. So this is actually, I believe, a hollow object. It's very interesting how that turns out. So, and then you change the two radiuses. One's in it, I believe, one's the radius from the center to here, from center to center, and then the radius of the second one's just the radius of this here. So we kind of want a solid object, so we'll get that to 180. Yeah, we want our solid object. We want that. That's a lot more handy. And so, see that radius there, how that's changing? And then this radius here, if we want to change it. So, that's how that works. That's a torus. I've gotten very, very creative in the past with using all of these shapes. Just these basic shapes. It turns out you can do things. I actually even did a rocket nozzle one time with just a cone and a sphere, and to create kind of the arc to it. I never 3D printed it though. Maybe I'll show you guys in a following video one of these days. So that's how you do that. That's all those geometries. So it's pretty cool. That's kind of the 3D side to it. So we're going to take a look here. So we've done that. We've done all these 5 shapes. Now we're going to look at some of the more advanced shapes. So box, cylinder, cone, sphere, ellipsoid. You haven't seen that. Torus, you've done it. Prism and wedge. We'll take a look at those. So we're going to do ellipsoid right here. So we're going to go ahead and create it. It's much more handy to do it that way. So looks like like a pancake. So we're making a bit of a pancake here. If you're familiar with ellipses, if you've done like college algebra or something, very familiar with that. If you're familiar with orbits, you know what an ellipse is. It's just like the 3D version of that. But this is like the different radiuses of it, the semi-major axis and whatnot. So you're just kind of changing those, right? So let's make it like really long. Let's say 20 millimeters, right? This has its own points of being handy. It's very, very nice. We'll create that to 0.5. So we're making a very oddball pancake here. This could actually be a halfway decent aerodynamic shape. You could be designing a surfboard even. So that's an example of what may come in handy here. If you would want me to design something particular, just kind of see how it's done and just get in that general area, just go ahead and post it in the comments and I'll do so. It'll be fun. We got these angles here. If you remember the sphere, that's much like those angles. Yeah, these the geometries are kind of hard to explain and how they work, so might look into like this one. This is fairly straightforward, but these two are kind of hard to explain. You may look into ellipsoids. I may make some separate videos on it. Might look it up for the time being, and we'll get into that. So. Alright, but let's keep our surfboard. So, we've got that. Pretty sweet. Now, we've created the ellipsoid. Alright, whenever that happens, you don't really want to do it in 0.17. It's a lot handier in 0.17 than it is here. So, just right click on the object, finish editing. So, we'll get into that at a later time. So now we've created an ellipsoid. Now we got to move into prisms and wedges. So prism, polygon of your selected sides. Interesting thing. For those of you that are unfamiliar with geometries and such, a polygon with an infinite amount of sides is a circle, which kind of makes sense. So circumradius and height. All right. And we can make multiple if we wanted to. We could, we can go decagon, change the height around, make it smaller, create a new one. So this is very, very handy. Unlike in like part design where you had like a limitation on the amount of sides, this doesn't. So you might find yourself, another common thing people may not do is use a combination of workbenches to do various things. Because this is very object oriented and you can use these Boolean operations kind of across the board. That's very nice. So whenever you start a part in part design or something, you don't have to make the part entirely in that one. It would show maybe some skill if you did, but you wouldn't have to. And it's honestly better if one was to learn all the tooling and be able to effectively cross-platform it between workbenches. Sorry if I sound a little nasally here. I'm a tad sick. Hope you guys are doing well. Creation of paramite. I can't pronounce, man. I'm terrible. Wedge. That's kind of the last one. So this is it doesn't make sense to show it here. Instead, I just want to go ahead and create it and show you guys the wedge itself. Now, X-min. Now, pay attention to this 3D coordinate system here. We'll go ahead and place it like this. Pay attention. So X-min you can kind of see that changing. X max, so that changes that side. Okay. Y max, you can kind of see where that's changing. Y min, so yeah, pay attention to that right there. Z axis, see where that's going. Z max, so Z refers to this side. Z2 refers to the other side. So we'll change the other side, so X2. You can see where that's going, right? Once again, kind of paying attention to that 3D coordinate system there. Z. So that's basically what that is. Those are just changing those values around. You know, if you wanted to create great pyramids of Egypt or something, and you wanted to showcase this to your teacher in class, or something of the sort, this is a very good program. In fact, one of my professors, I believe, at a college of mine, was halfway impressed with this when I showed him, and what it could do, and what the open source community created. So that's all like the 3D primitives. In part 6, we're going to go into more Boolean operations, and then also probably these here, and in creating using the Sketcher Workbench to create a sketch, which we learned in previous parts and previous tutorials, to furthermore use those sketches to create like your lofts, your sweeps, and even these are just basically sketches. They're basically sketches. So that's how that is. Alright, thanks guys. Bye.